Alright, so let's kind of mix and match and put some things together. We are going to flip a coin, and we're going to flip that coin 10 times. And I want to find the probability of flipping 8 heads. If I am flipping the coin 10 times, that means n is 10. Now I know when I flip a coin, the probability of flipping a head is 1/2. And that means the probability of flipping not a head, or a tail in our case, is also 1/2. If I want to find the probability of flipping 8 heads, no normal approximation is required here. If I want to find the probability that 8 heads are flipped, then I can take 10, choose 8. Out of the 10 coins that I flip, I want 8 of them to be heads. 0.5 will be to the 8th power, that's my P, and my Q will also be to the 8th power. Alright, my hands and my eyes and my mouth aren't working today. This should be the 2nd power. 8 heads, 2 tails. This needs to add up to 10. Okay, when we type that into our calculator, we get 0.044. If I want to find the probability of flipping 2 heads or fewer, that means 2 or 1 or 0. So the probability of flipping 2 or 1 or 0. Go ahead, if you would, and don't approximate this, and we'll come back and see if we can, and then compare answers later. But go ahead and find probability x equals 2, and then x equals 1, and then x equals 0, and turn it on and see what that is. Probability of flipping 2 heads is the same as flipping 8. 1 head is this, and 0 heads, that's a 10, is very small. So about a 5% chance of getting 2 or fewer. Maybe I wanted to practice my approximation, my normal approximation to the binomial here. So before I do that, I need to check n times p and n times q and see if they're big enough that I can do that. If we take 10 times 0.5 and 10 times 0.5 again, then since both of those numbers are greater than or equal to 5, we can keep going. Now, n times p is also just mu, so I have that part already computed. And if I want to take 10 times 0.5 times 0.5 and take the square root, we get something at 1.58. Now, if we're going to do the normal approximation to the binomial, we said the area under a single point is 0. The area under just the number 8 is going to be equal to 0. But if I need to make that area half a unit wider on each side, what that means when we're using the normal approximation is that we have to figure out the probability that x is between 7.5 and 8.5. We have to give width to this interval. We have to pretend that it's continuous and that we can flip 7.8 heads or 8.45 heads. So we will turn each of these using our mu and our sigma. We will turn each of these into z-squares, subtract and find that area in between. Down here, our mean is 5, so 2 is here to the left. If I want 2 or fewer, I have to make that area half a unit bigger. I'm going to leave it all black right there. So we're going to have to find the probability that x is less than or equal to 2.5 by turning 2.5 into a z-score and then finding that area to the left. Go ahead and pause the video and do those two things and see how close it is to the actual exact answers that we found. So between 7.5 and 8.5, the z-scores are 1.58 and 2.22. If we find that area between, that's exactly what my calculator told me up here. So this was a pretty good approximation. Okay. Now our exact value, what I'm going to call the exact value from our tables, or from our calculators, was 0.0547 for 2, 1, and 0 added together. If we use the normal approximation for the binomial, we get 0.0571. So this is just over 5.5%. This is just right shy of 5.5% chance. So they're close. You can see they're not exact, but they are going to be close. So let's say now that we're going to flip a coin 50 times. If we're going to flip that coin 50 times, we most definitely, we want the probability of getting at least 30 heads or fewer than 20 or between 20 and 30. We for sure want to use the normal approximation. Okay, go ahead and pause the video and give these guys a shot. Make sure to check to be sure you're allowed to do that before you do the problems, and then come back and we'll do the problems. The probability of flipping at least 30 heads means we're including 30. That means 30 or more. So if we want the probability of getting 30 or more heads, we need to correct for continuity by making x 29.5. That makes our z 1.27. Area to the right means 1 minus the value that we find in the table. Okay, the probability of flipping fewer than 20 heads means 19 or less. If we are 19 or less and we correct for continuity, we're at 19.5. Change that to a z. Use our table. We don't have to do anything extra. Between 20 and 30 does not include either 20 or 30, so that means from 21 to 29. And if you need to write all those down, I've quit writing them, as you can see, but write down as much as you need to get that continuity correction correct. Okay, so if I'm bigger than 20, I'm from 20.5 up to less than 30, should be 29.5, which means the rest of this is wrong, so give me a minute to fix it, and then I'll be right back. My apologies for all the foibles. It's obviously not my morning. Okay, so less than 30 means stopping at 29. Making the area half a unit bigger is 29.5, which is 1.27. That makes more sense because 25 is in the middle, and so this should be a symmetric situation here. And then our area, we subtract, and we say almost 80% of the time that will happen. Here only 6% of the time, here about 10% of the time. Please contact me if you need me to do some more of these problems with you. But I think this is a good place for me to stop, considering. Have a good day.